This is an A-level mechanics question on forces and friction. A wooden crate of mass 20 kg is pulled in a straight line along a rough horizontal floor using a handle attached to the crate. The handle is inclined at an angle alpha to the floor as shown in figure 1, where tan alpha is 3/4. The tension in the handle is 40 newtons. The coefficient of friction between the crate and the floor is 0.14. The crate is modelled as a particle and the handle is modelled as a light rod. Using the model, part A, find the acceleration of the crate. So the first thing I'm going to do is to put on all the forces on this diagram. So the 40 newtons needs to be split up into its horizontal and vertical components. So I'll have 40 cos alpha going horizontally and 40 sine alpha going vertically. In the opposite direction, I will have a frictional force F, which is going to be equal to mu R, and I'm also going to have a normal reaction of the crate upwards and the weight of the block going downwards, which is going to be 20 g, and it's accelerating to the right. That makes sense because that's the direction it's being pulled in. Now I'm just going to go back to this tan alpha being given as 3/4, and what I'm going to do is to work out from this the exact value of sine alpha and cos alpha, because I'll need those in a moment. So just draw a right angle triangle like this, call this angle alpha. Tan is the opposite over the adjacent, so the opposite is 3, the adjacent is 4. Using Pythagoras, that means the hypotenuse is 5. So I've got exact values for sine alpha, that's the opposite over the hypotenuse, so that would be 3/5, and the exact value for cos alpha, which is the adjacent over the hypotenuse, which will be 4/5. Okay, so let's start by resolving the forces going vertically. Now these are going to be balanced because it's not accelerating in this direction, so I can write that R going up plus 40 sine alpha going up is equal to 20 g. Now that sine alpha, we have an exact value for 3/5, so I can actually write R plus 3/5 times by 40, that would be 24, is equal to 20 g. So from this I can actually work out the value of R, and R is going to be 20 g minus 24, and using g as 9.8, I get R is equal to 172. Okay, so I'm just going to highlight this because I will need this in a moment when I resolve horizontally. Now when I resolve horizontally, I will be using F equals ma because this thing is accelerating and it's accelerating to the right. So what are my pulling forces? Well, 40 cos alpha is the only pulling force, and the force resisting that is mu R. So minus my frictional force F, which is equal to mu R. So that will be mu, which is 0.14 times by R. And that will be equal to ma. So the mass of 20 times by the acceleration, which we're trying to find. Now cos alpha, we know the exact value for, which is 4/5. So we're now going to work out 4/5 of 40, which will be 32. And now we know the value of R because I highlighted it earlier, didn't I? So that means that I can take this 172 and put it here. So I'm now going to work out 0.14 and times that by 172, and that gives me 24.08. So 24.08, and that is equal to 20A. So if I divide this by 20, I'm going to get my value of A. So let's see if we do that, what we get. And that gives me exactly 0.396. Now, we should always give our answer to 2 or 3 significant figures anytime we use a value of G of 9.8 in our working. This answer here is 3 significant figures, so I don't need to round that. But I could also give my answer to 2 significant figures. So an alternative answer, if I round this to 2 significant figures, would be 0.40 meters per second square. Okay, so the actual rounding to 3 significant figures doesn't affect the answer on this particular question, but do watch out for that. The crate is now pushed along the same floor using a handle. The handle is again inclined at the same angle alpha to the floor, and a thrust in the handle, it was tension before, the thrust is 40 newtons as shown in figure 2 below. So this is the same 40 newtons as before. This is the same angle. This is the same 20 kg as before. Part B, explain briefly why the acceleration of the crate would now be less than the acceleration of the crate found in part A. Now, to do part B, I really need to compare the forces that I had in part A with part B. So this is a diagram for part A, and let's put on the forces for part B. So I will have R here, 20G going down. I will have 40 cos alpha going horizontally, and then vertically down 40 sine alpha. Now, the first thing that strikes me is that this 40 sine alpha is in the opposite direction in part B to what it was in part A. Part A was pointing up, part B is pointing down. Now, if the acceleration is now less in this part of the question, it means that the forces have changed. Well, the 40 cos alpha hasn't changed, so let's cross that out because that's the same as it was before. It's still pointing in the same direction, it's just on the other side of the block. That's going to make no difference to the acceleration. The only other thing that's going to make a difference to the acceleration is the mu r, and I need to put the mu r on my diagram here. So pointing in the opposite direction to my 40 cos alpha. And if this is changing, the frictional force, and mu is fixed, then r must be changing. Let's see why and how that happens. So let's start with a diagram over here and write that equation down that we had for r. So r plus 40 sine alpha is equal to 20g. So in this part of the question, if I wanted to find r was going to be equal to 20g minus 40 sine alpha. Okay, let's look at how we work out r over here. So r, so I'm resolving vertically, is equal to 20g plus 40 sine alpha. Right, okay, so when I did part A, it was 20g minus 40 sine alpha to get r. In part B, it's 20g plus 40 sine alpha. R is bigger. Now, if r is bigger, that means that mu r is bigger. 40 cos alpha hasn't changed. So I'm going to be subtracting a larger number away from 40 cos alpha to find the resultant force. That will mean that the resultant force is smaller, which means that the acceleration will now be less. I want to explain that in words. So what I've put here is that since r will have increased from part A, and I've put the equation to show why it's increased from part A. So in part B, r is 20g plus 40 sine alpha. In part A, r was 20g minus 40 sine alpha. Therefore, the resultant force will decrease, meaning the acceleration will be less, or the acceleration will decrease from part A.